Math 2, Unit 4.2. Today we're talking about perpendicular and angle bisectors. What does it mean when you bisect something? You cut it directly in half, which means that you end up having two equal segments. Yes. Okay. Also, what does it mean when you have a perpendicular bisector? Perpendiculars make right angles. Very good. Okay, so let's go ahead and read through here. So this is what we're trying to make sure you get out, essential understanding for this unit or this section. So there is a special relationship between the points on the perpendicular bisector of a segment and the endpoints of the segment. Okay, in this diagram below, CD is the perpendicular bisector. So you can see CD, this line, is the perpendicular bisector of AB. Okay, so when CD cut through here, it made two 90-degree angles, and it made two equal segments. Okay, CD is perpendicular to AB at its midpoint. Okay, in the diagram on the right, CA and CB are drawn to complete this triangle. So they did the perpendicular bisector, and then at point C, they connected the lines to actually make it a triangle. You should recognize from your work in Chapter 3 that these triangles, triangle CAD, so this side, and triangle CBD are congruent. So you can conclude that line CA over here is congruent to CB over here. So we do like two lines on these. A point is equidistant. What does equidistant mean? Equal distance, very good, from two objects if it's the same distance from the object. So point C is equidistant from points A and B. So what it means is if you have these 2 points right here, since these are equal, when they go to the same point up here, that these two segments are going to be equal. They're not necessarily equal to the segments at the bottom, but these two segments will be the same because they are going to the same point. Okay? So this suggests a proof of Theorem 25, the perpendicular bisector theorem, and its converse is also true. Okay, so here are the theorems. So this is on page 208 now. All right, so if a point is, here we're going to start here. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segments. So they've done the same thing right here. So PM is a perpendicular bisector of AB, so that makes two 90-degree angles or two right angles. And we know that PA will be congruent to PB because it's going out the same distance. Since these are the same distance, those are the same distance. Okay? The converse is true. So converse is giving you the opposite information. So they're telling you that if you know that PA and PB are equals, if you were to take a perpendicular bisector, okay, then you would then know that these angles would also be equal. Okay, or sides. Do we have any questions on that? Okay, we're going to move on. All right, so we are still on page 208. Okay, what is the length of QR? So who knows how we would be able to find it? If this is a perpendicular bisector, okay, and they already told you that these two lengths are equal, if these two lengths are equal, then what do we know about these two lengths? They also have to be equal. So how could I solve this equation? Exactly. So we have 3n minus 1 equals 5n minus 7. So I'm going to give you a minute to solve that. Once you get the answer, you can actually show me on your fingers. So tell me your answer once you get it for n. Nope. Just for n, not the complete answer, just n right now. Good, good, no, yes, 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 yes. So I'm just looking for the answer of n. Good. 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 Okay, so the correct answer is 3. So we're going to go ahead and solve this. I would subtract 3n to both sides. These cancel. I get 2n over here. And then I'm going to add 7 to the other side. And we get negative 1 and 7, which makes 6. Divide by 2. And you get n equals 3. This is where people usually make a mistake, but most of you actually didn't. And that they didn't ask for the answer of n. They asked for the answer of QR. So we go to QR, which is 5n minus 7, and we plug in our answer of n. So we get 5 times 3 minus 7, 15 minus 7 equals 8. So QR equals 8 is my answer. Okay, do we have any questions on that problem? So one thing that you need to always remember is that once you find an answer, you always want to go back and check your question again to make sure the answer you found is what they actually asked you. Okay? All right, practice problem A here. It says use the figure at the right for exercises 1 and 2. First question, what is the relationship between MB and JK? So what's this relationship, those two? So in your group, state what you think. What is the relationship? All right, so this is the wrong class. Does somebody want to tell me what the relationship is? Carlos, thank you. What is? Good. So MB, line MB, is the perpendicular bisector of line JK. All right, and number 2 says find JM. So I'd like you to do that. Find JM. Once you get the answer, you should be able to show me on your fingers. Good, good, good. Remember to read the question. What are they asking for? You have part of the answer, but that's not what they asked you for. Okay, that's part of it, but that's not the answer they're asking for. There you go, good. 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 Okay, so the correct answer for JM is 9, but in order to get that answer, you first had to figure out, well, what does X equal? And so since these are equal and it's a perpendicular bisector, we know that these two lines are also equal to each other. So we should have set out 9x minus 18 equals 3x. In order to solve, what would you do? Good. Subtract 9x to both sides, so all your x's are together. So negative 18 equals negative 6x. Then we divide by negative 6 to both sides. X equals 3. Once you have that, we plug it in for JM. It's kind of, could I have just, instead of plugging in for JM, since I know these two are equal, is plugging in for MK easier? So I'm just going to go 3 times 3, and that equals 9. So JM equals 9. Okay, did anybody solve it differently? Did you do it different, Shelby?
Yeah.
Do you think you did it more difficult? Okay. Then we won't have you explain the more difficult way. All right, do we have any questions on what I've done? No? Okay, I'm going to have you go ahead and move on to page 210. All right, so essential understanding here. There is a special relationship between the points on the bisector of an angle and the side of the angle. So the distance from a point to a line is the length of the perpendicular segment. Wait a second, am I reading right? The distance from a point to a line is the length of the perpendicular segment from the point to the line. This distance is also the length of the shortest segment from the point to the line. Okay, we're going to prove this in lesson 4-6, which we're not to yet. But in the figure at the right, the distance from A to L, so right here, and B to L are represented as red segments, so you can see it there. In this diagram, ray, AD, so they took AD, is the bisector of this angle. So when they bisect, they make these two little arcs. Because if they're bisecting an angle, right? If you're bisecting an angle, it's going to cut it in half. So each of these are the same degree. Are we focused? Okay, so AD is a bisector of this angle, so that means these two angles are the same, which is why they have only one little line for your arcs. If you measure the length of the corresponding perpendicular segments, so right here, from D to the two sides of the angles, you'll find that the lengths are equal. So basically, if your angles are equal, then that means your lengths will also be equal over here. Point D is equidistant from the sides of the angles. So I feel like we have talked about this before, but if you have two angles that are the same side, then that size, then that means these sides are going to be the same amount as well. Now, will this side length, do you think that this is 3 degrees right here? No. So it's not like there isn't a relationship between the number value for the arc and the number value for the side. But your number value for your angle is equal and the number value for your sides are equal. Is that clear? Can you guys restate it in your groups what we're talking about here? Okay, can somebody restate it to the class for me? Like a different, however you said it. Can you say it for the class? So if nobody wants to say it, that means you guys don't get it. Is that right? So we're not sure that we understand? So if you're bisecting an angle and they're saying right here that this angle, this little angle is the same as this little angle, then what that means is that when you go and you cut this out in half right here, this side is also going to be equal to this side. So if these two angles are equal, then that means these two sides are also equal. Okay? I think sometimes it's easier when we start putting numbers in, maybe. We can always come back to it if we need to. So still on page 210, okay, the theorems. Okay, so they're saying the same thing here. So if you bisect this angle Q, okay, PQS, right here, is equal to SQR. That also means that PS is equal to SR. Okay, so they're showing you here that the angles are equal and your sides are equal. And then the converse is true. If you have two side lengths here that are equal, then that means that the angles will also be equal if you draw the line between these two. All right, are we ready to try some examples? See if we can put this to our knowledge. Okay. It says, what is the length of FB? Well, what am I going to have to do in order to figure out the length of FB? Is there an equation I can set up? 6x plus 3 equals what? All right, let's figure it out. So tell me what x equals before you tell me the answer for FB. So show me on your fingers what answer you get for x. Good. Good, 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 good. Good, 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 good. You got it? Got it. Good. Yes, question. I do. Yeah. Good. Okay, and right now we're on page 211 in case you didn't know. Okay, so the correct answer for x is 3. Good. Okay, so we subtract 4x to both sides. This makes 2x plus 3 equals 9. I subtract 3 to both sides. I have 2x equals 6. Divide by 2, and x equals 3. But is that my final answer? No. So in order to find your answer, we have to plug that back into FB. So when you do that, what do we end up getting? 21 is correct. 6 times 3 plus 3. 6 times 3 is 18, and 18 plus 3 equals 21. So 21 is the distance of FB. Okay, any questions there? All right, on this next one, it says find the measure of KHL. So, where are we at? Right? K to H to L. They want to know what is this angle's distance. So, in order to find that out, what equation would I end up setting up? So, good, equals this. Because if these two sides are equal, then that means that the angles that they match with, those angles will also be equal based on our converse theorem, right? Okay, so you should solve for y. 6y equals 4y plus 18. And what answer do you get for y? Show me on your fingers. Good. No. Yes. Yes, 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 yes. No. Yes, yes, yes. Nope. Yes, yes. Yes, yes. Okay, so you should have got 9. All right, so we'd subtract 4y to both sides. 2y equals 18. We divide by 2 to both sides. 18 divided by 2 is 9, right? Okay, and then how can I find out the answer for that angle? What do I do? Good, so we can actually just take 6y, and we go 6 times 9, and 6 times 9 is 54. Okay, so 54 degrees is my measure angle KHL. All right, the last one there, number 6, they want you to find the distance of JK, so from here to here. Okay, set up your equation and solve. And I'm going to have to come around and look at your answers. Who has an answer for the actual question? Make sure you're showing a little work, okay? So take this one. You get it? Perfect. So I'm looking for the final answer, not just what x equals.
We're just finding x or the whole thing?
The whole thing. Perfect. Good. You have the right answer for x. Now find the answer for JK. Okay, so the answer was 17. Is that what you guys got? The answer for x is 12. X is 12, and then your final answer is 17. So let me work through this real quick. I noticed as I was walking around, a lot of you were not showing work. You were doing this stuff in your head. When you do stuff in your head, you usually mess up. Okay, so write out your work when you're solving these problems. So I get 5 equals 2x minus x is x minus 7. And then I have to add 7. And so when I do that, I get 12 equals x. Okay? And then all we do is plug it in. So for JK, we plug it in. We have x plus 5. So 12 plus 5 equals, 5 equals 17 for JK. And we also need to find JM. Do you think it's going to be the same answer? It should be equal. And so let's try it out. So if I go 2 times 12 minus 7, what is 2 times 12? And 24 minus 7 does equal 17. So 17 is JM. Any questions? Okay, together we're going to do a few problems. So we're going to do the lesson check, numbers 7 through 9. Number 7, it says, what's the relationship between, and I think it's always a good idea to kind of highlight things, and it's saying between AC and BD. Okay, so in your groups, talk about it. What is happening? What's the relationship between those two lines? And for time's sake, we're going to go ahead and kind of talk about this together. But which one is the perpendicular bisector? Okay, and it is AC. AC is the perpendicular bisector of line BD. So if you look, do you see how this line is going through here, cutting it in half, making a 90-degree angle, and making these two sides equal? So that's why AC is the bisector. It's the one that's cutting another line in half. Okay? All right, so then it says, what is the length of AB? $15 is correct. So if you look here, do you see how it's where these two are equal here? That means that these sides over here have to be equal. So that is why AB has to be equal to 15. Okay, now DC, how much is DC going to be? Is equal to 18. Do we have any questions? All right.